Hello and welcome to the Dockyard Elixir Roundtable. I'm Nathan Long.
I'm Andrew Berrien.
Brooklyn, you're muted.
I'm Brooklyn Myers, and I don't know how technology works, apparently.
And Mike Benz.
Today we have a really exciting show because we have a guest on the show for the second time ever. This is Matt Trudell. His first time ever on the show. Is our second time having a guest. And Matt has created a couple of really awesome, exciting libraries, which hopefully are going to be part of all of our network stack in the near future. They are called Thousand Island and Bandit, which are two libraries that are similar to Rancher and Cowboy. So his first time ever on the show. Is our second time having a guest. And Matt has created a couple of really awesome, exciting libraries, which hopefully are going to be part of all of our network stack in the near future. They are called Thousand Island and Bandit, which are two libraries that are similar to Rancher and Cowboy. These two libraries are a lot of fun because of the way that he's building them and the things that they can do. And also, this gives us an excuse to talk about all kinds of fun networking stuff. So before we jump into that stuff, oh, and by the way, I found out about this because he did this ElixirConf 2021 talk called Bandit on the Loose, Networking and Elixir Demystified. And in that, he talks about a lot of the networking stack and the Berkeley sockets API and all that kind of stuff. But there's actually a newer talk that he just did called A Funny Thing Happened on the Way to the Phoenix at MPEX Mountain 2022. So both of those talks we'll put in the show notes, and you can check those out if you enjoy this discussion and want to hear more. Before we get into this too much, Matt, you want to tell us a little bit about yourself? Like, why did you decide to create these libraries? How did you have the background knowledge to do this? Anything you want to say to start out?
Sure. Well, thanks for having me on, first off. It's great to be here. So yeah, the gist behind these was that I originally wrote the two of them, Bandit and Thousand Island, as they were necessary diversions in this really long-winded yak shave that I'm still actually working through right now, to build a HomeKit accessory protocol server for Elixir. We have one of those ductless air conditioner units in our hallway. And then you have those junky little remotes, right? The little infrared remotes that you can't control from your phone. You can't control remotely. So if you're coming home and you want to, juice the AC up so the house is nice and cool, you can't do it. So I wanted to build a little Raspberry Pi that had a little IR blaster on it that you could control from HomeKit. And it kind of one thing led to another. And in the process of building that, I ended up having to build a web server and a socket server underneath that for a number of necessary but completely ridiculous low-level reasons, and kind of fell into this. Like, I kind of fell backwards into it. I was like, I've already built this thing. It's kind of better than Cowboy already, so I'm just going to keep running with it. And I just can kind of refine the abstractions on it, working on the ergonomics of using it for both for web stuff and also for like the lower level socket stuff that we'll talk about with Thousand Island. But the short version is it basically happened by accident. I kind of fell into it backwards while doing something completely different.
I love that this whole thing is like one giant yak shave for you.
The original, well, so this was actually before COVID. It was before COVID. It was in the before times. And my wife volunteers in the evenings quite a bit. So she's out in the evenings. We have a young daughter, so I have to be home. So whatever hobbies I have, I need to be able to do them at home. And so I just kind of came into this idea, I don't know, 4 or 5 years ago, that like, I'm just going to start taking on these things that the journey is the point, where I'll work on these libraries and I'll do something mostly just frankly to fill the time, so if I'm on something where it's like, it's, this multi-year yak shave and step one of it is going to take me 18 months. Okay, that's fine. I'm not shipping anything here. This isn't a side hustle. I'm not trying to make, I'm not trying to build us like a, passive income here. It's a fun hobby. So long as it's fun, I don't really care what part of the stack I'm working on.
That's awesome. But you did say, like, as this sort of vision developed, you've gotten to the point where, like, in your talk, you said you're hoping eventually these will be the de facto networking stack for Elixir.
Yeah. Well, and I think I don't know if anybody's ever tried, because this is what the original. So the original idea, that HomeKit library I was talking about, is called HAP. It's also on my GitHub if anybody is interested in HomeKit stuff. The original impetus for having to write this custom stack is the HomeKit accessory protocol. It works on HTTP, right? So every light bulb, this is for the Wi-Fi stuff. There's a accompanying Bluetooth spec as well, but for anything that's like a HomeKit Wi-Fi device, everything in your house that's like that runs a little web server on it. So every light bulb, every switch, whatever, there's a little HTTP server on it, and there's like a half dozen endpoints to get parameters and set parameters and stuff. And all of that runs on this really esoteric encryption layer, right at the TCP boundary. So it isn't SSL. It's not certificate based. You negotiate this key and the first time you set a device up, and then you just use this for this really simple little like encryption layer at the bottom. And so I'd originally tried shimming that into Ranch, the library that sits underneath Cowboy. And it's ultimately like, it reduces down to like, I don't know, maybe half a dozen lines. Grab a key from somewhere in your application, take any bytes that you want to send and run them through that key, and then send the encrypted stuff. Like it's literally like 1 or 2 extra lines, and do the inverse of that when you're receiving data. And it was just 1 or 2 extra lines. And I spent a couple evenings looking at the Ranch code, and I was just like, this is not fun. Like, I'm just, like, no shade to Erlang. It's just a different style. Like the idiomatic Erlang doesn't look like idiomatic Elixir. That's fine, but it just wasn't fun. And it was like, I wasn't super sure about this. And it was, I was like, I'll just add another layer onto the Yakshave and build a web server. How hard can it be? And so the earliest days of it were really kind of based on that, on this idea of just kind of building up from there. And then as I worked through it, I was like, you're looking at the abstractions, because the abstractions that Ranch has, so Ranch, if y'all don't know, is like the library that sits underneath Cowboy, right? Because cowboys live on a ranch. Right. And so Ranch basically provides like a set of tools to be able to like listen on a numbered port, and then have a function, or in the case of Ranch, it's actually spin up a process with like that handles every new connection that comes in. So if you're running, like a web server that you implement on top of Ranch, every client that comes in Ranch will hand you a new process with the details of that connection. And then your application, your HTTP server, or whatever it is you're writing, goes and does whatever it likes to, it wants to with that connection. And those abstractions are actually really great. Like they're almost the exact same abstractions that I expose in Thousand Island. Like they got that part super right. It's just the implementation is just kind of dicey to work with in Erlang. But I kind of refined that a little bit and a little bit and a little bit. And then I ended up building in Thousand Island the handler behavior, which is like the main interface that higher level libraries use to be notified of connections. And it's turned out to actually be like it's far more ergonomic than I could have ever hoped. Like I've written probably a dozen different samples and demos and stuff in the course of both this and also just some other work that I've been doing, and demos and talks that I've given. And every single time it's like, this is a joy. Like this just works really, really, really well. I don't know how I managed to do it, but I think I really captured the, what you actually want to do from a networking perspective. And then so you can end up writing, like I think in the Elixir Conf talk, I do a demo of the Echo protocol and the Daytime protocol. I think about halfway through, they're like these old 1970s era RFC, internet RFCs. And they run on like port 10. Like they're like some of the earliest things that people ever did on top of TCP. And like a complete implementation of this that is like literally the fastest and most scalable Echo server that's ever been written and ever will be written in the world, that could do 100,000 connections at once and not even break a sweat, is like 11 lines of code. Like it's just, here's what you want to do when somebody connects, here's what you want to do when they send me data. That's it. Like it's just super expressive.
Yeah. People sometimes talk about the things that Elixir isn't great for in terms of like raw compute speed and stuff like that. But one thing that strikes me is that this is something that Elixir is fantastic for. That the Beam model is just fantastic for like managing incoming connections, and like you said, giving each one its own process, and handling those fairly, like scheduling all those things. Like it's
Yeah, absolutely.
beautiful for that.
This was one of the things I also gave a talk last week, early May at MPEX Mountain, where I talked about that was the funny thing happened on the way to the Phoenix talk. And the emphasis of that talk was a lot more about like the process models that end up living in these network layers and like what the process model within Bandit and within Thousand Island looks like. And it turns out that like this stuff is really textbook OTP. Like when you first start learning Elixir, and you first crack open like the chapter on supervision and on gen servers and on on process linking and stuff, it's really abstract. But I think like networking in particular is like a super focused, like that's the stuff they wrote the language for, right? Like this is what they had in mind when they built, when they were first sketching out what the stuff looked like. So it hews very, very, very closely to the patterns that the language provides. It's a really good kind of textbook example of like, here is what, here's what the elders expected OTP to look like. Here's how they want you to use it, and it works really, really well as a result.
That's awesome. And in your readmes on these two projects, you talk about some of the things that you have been able to achieve. I'll just kind of like throw these out real quick. We'll come back to them later, but like really good speed, code brevity and clarity, full featured, well tested, standards compliant, configurable. You're using telemetry. You're not logging stuff, which I love. You've got this simple handler behavior you were talking about. You've got the self-contained process tree, so you can run multiple of these on different ports within the same application. Idiomatic OTP, like you were just saying. Bandit is purpose written to work with plug, was something you talked about in your talk. So a lot of really cool things there. But before we dive into all that, I'd love to just, for people who don't have a good sense of like kind of how the internet works, can we do a little kind of storytelling of like a browser calls up a server?
Sure.
Like
isn't this like one of the classic Google interview stories?
Yeah.
What does the DNS lookup look like?
Right. Yeah. I don't think we have to give not necessarily every single detail, but yeah.
Sure.
Tell us that story.
Right. So the general idea is you have clients and you have servers, right? And servers listen for connections and clients connect to servers. And those, and like listen and connect are actually the two names of the functions in the Berkeley API. Right. And this stuff, like the Berkeley API is the underlying sockets, the underlying API that it is how operating systems expose the internet, expose TCP/IP to processes. It's as old as the hills, right? The stuff is from like, I don't know if it's in like the C programming language, like the classic black and white or blue and white, Kernighan and Ritchie book. I think it is, but it's of that vintage. This stuff is old. And the interfaces that we use today for this stuff, by and large, still, I mean, some people are trying to reinvent it, but generally speaking, everybody that works with Socket, that works with the internet, works with these calls at some point. You're not making them yourself when you're writing Phoenix code, but somewhere down the stack, somebody is. And that's really what the job of Thousand Island as a library is to do those. So within that, you've got essentially a connection gets made, right? So a server starts listening for socket for connections, and that's when you pass in the port number. So like you'll listen, let's say on port 4000, and then the next thing that the server does is call this accept function, and accept essentially sits there and waits until a client connects. So listen basically makes the port available for a client to connect to, and then accept handles an actual connection. And then once that connection comes in, you get both the client and the server get a socket that's returned to them. So the client gets it from having connected, the server gets it from having accepted that connection. And that socket basically is just a pipe. So you throw bytes in one end and they come out the other end. And if and those they're like the two directions are totally distinct of each other. And that's really all there is to it. Those bytes can be whatever you'd like. They can be, you can type in ASCII at one end. Like if you've ever done, if you've ever used if you go to like telnet localhost 4000, and you just get back a prompt, or like, I guess these days you have to use like NC localhost 4000 because Telnet doesn't come with most OSs now. But you can actually sit there and start typing because you're actually connected to you have that at that point connected to the server that's listening, and like a web server that's listening. You can actually write HTTP by hand, right? You can type in, capital GET/HTTP/1.1 enter again, and you've just issued a valid HTTP request, right? And the server will respond to that. It'll typically just, like vomit back an entire HTML page of the front page of the thing. But like that's a valid, that you're passing data back and forth. There's no magic to it, right? That data can be ASCII, it can be binary if you'd like, if you wanted to, fire up send a binary file back and forth. They're the same calls, but the abstraction's pretty simple. There's some other details on top of it for, there's certain levers you can start tweaking for performance, for doing other stuff. And some people are trying to reinvent this for higher performance things now. I think Google's pretty active in that, but ultimately that's the abstraction that sits under everything we do on the internet.
Yeah. And just because I think this is a fun topic, I want to tell a little bit of the story of like what's happening behind that magical socket. So like, as I understand it, at least in the very early days of networking, you would have like two universities that had these big computers, and they might actually have like a dedicated line between those two universities. Like this wire goes from this computer to this computer, basically, right? But that doesn't scale at all because you can't have a wire from you to everyone. So when they moved to IP, it was like, we have this whole network of servers, and what we're going to do is we're going to chop up our requests into packets and just send them out, and we're all going to share the same network, and our packets are all just going to get routed where they need to go. And that's what IP packet routing is all about. And just like from this IP address to this IP address, the packet needs to get there somehow, and that IP address represents a machine on the other end somewhere, but it has no concept of like which program running on the other machine is it supposed to go to. So, and also it has no concept of like these packets are all part of the same request, or they need to arrive in this order. And so TCP adds on top of that, this packet is packet 1, this packet is packet 2. When they get to the other end, if they arrive in the wrong order, reshuffle them. If one of them doesn't get there, like it won't be acknowledged, so the sender will know to send it again. And all this stuff is happening. TCP is giving you this reliable connection from one to the other, so that when you put in your GET request and the server sends back its response at the application level, it's just saying, here's our text response. Like TCP is making sure magically for you that all those packets get where they're supposed to go and get assembled, and like that data pops out the other end of the socket. So like from the client's perspective, you just said, give me this into the little telephone, and like the server says, here it goes, and comes back into the telephone, but like all the magical packet stuff is happening between those two sockets. So like, and also like at the packet level, it's like a nested series of envelopes, like kind of being taken on and put off, like put on and taken off as it goes along through the network. So that's all super fun. There's that like receive loop right on the server side where you're saying, okay, I'm gonna accept this incoming request, and at Thousand Island, like the whole job there is to like manage that receive loop, right, and take care of having the processes that hold on
exactly
to those connections.
Right.
And
like the simplest version of that of a server that you could build is something that literally just does all of that in a single loop, right? So you have a loop that's like accept a connection, handle the connection, accept the connection, handle the connection. And that, I mean, it works, except that it means that you can only, like, if this helps to illustrate it, that means you can only have a single client connected at a time, right? Because you only have a single process that's doing that loop, right? So, when you accept a connection, you pick the next client that comes and you process that connection. Let's say that processing takes 10 seconds. Right, that's 10 seconds that you're not being able to service any other clients that are connected. So you end up having clients essentially queuing up, waiting for there. And so this is so what we do in Thousand Island is every time you accept a connection, you spin off another process, a supervised process, to go and handle the long running parts of that connection. And then you immediately just come back to the top of the loop, accept the next one. So that
Gotcha.
that there's less time for that.
So the server thing is just like accept handoff, accept handoff, accept handoff. Like
Exactly,
as
exactly.
fast as
Yeah.
possible. And then those
Yeah, and
acceptor processes are dealing with sending back responses as needed.
Exactly. And they can do that at their leisure, right? This is the great, one of the great things about the process model is that like those things that get spun off are just processes. And in point of fact, in Thousand Island, they're actually just gen servers. And so you can write in your handler any other gen server code you'd like. And so you can build something like, I think I have I think there's an example of this in the Thousand Island repo, like a messenger application, where when you connect, it basically just gives you back your PID, and then you can message other people's PIDs, other people on other PIDs, and it just, because they're all processes, they're all just sitting there waiting for your standard handle connection, handle call, handle cast style gen server calls, and they can do whatever they like in those calls, including send data to the client that's at the other end of that. So you have this process sitting server side that kind of is essentially a gen server that has access to the client remotely, and it can do whatever it likes to. It can wait for data coming in from the client and then do something, act upon that within the application, or it can take data the other way, take data from the application and then send it out asynchronously to the client. So you can do things like building like a messenger application and like maybe 50 lines of code, basically whatever you need to do to be able to look up the remote end and, send them off a message.
So building on top of Thousand Island, because it's handling basically all the stuff to do with TCP connections.
Yeah.
You can build on top of that any application layer that you want, right?
Exactly.
Somebody could take Thousand Island and be like, I'm going to build an email server, or I'm going to build an FTP server, or whatever.
Absolutely.
Anything.
Absolutely. Yeah. And in fact, the like the echo and the daytime examples that I have in the talk, they're actually, I think I repeat them in both talks. They're also in the MPEX talk as well. Those are like, they're fully featured. They're done. That is an implementation of Echo right there in like 7 lines of code. And it takes for granted all of that scalability underneath it, right? So your applications focus just on the particulars of their protocol, right? So for, a simple, daytime is obviously a bit of a simple, because it literally just writes out the current time in ASCII and then sends it. Like it's about as simple of a protocol as you get, but like it's complete, it's done. And it's all the things that aren't there that are notable, right? It's all of these things about scalability, about, ensuring that you're, able to process multiple, like the concurrency aspects of it. Those are the things you don't have to think about, which I think is the real power of like a good socket server API, right? And so Bandit as an HTTP server that sits on top of Thousand Island doesn't have to think about any of that, right? It literally just has to worry about, I've got the single client that's connected to me, and I'm just going to transact HTTP with that single client. So it's literally just the bits and bytes that correspond to a particular HTTP connection, and it doesn't have to think about the scalability aspects of it at all.
That's really cool. And just to kind of build on that, like, because the application layer is this whole separate, like built on top of something like Thousand Island. Like if you're listening to this and you're like, I would love to write an alternative to email. Like I like to invent my own protocol and write something that's like email, but better, or, whatever you have in mind, you could invent that protocol and you could use Thousand Island as the connection, the connection management layer, and then
absolutely
talk whatever you want to talk over that socket.
Absolutely. There was a person at the Toronto Elixir night meetup where I first introduced Thousand Island a couple of years ago, who went off and like a few days later came back to me, and he'd written a SOCKS server, a SOCKS proxy. I don't know if any of y'all are old enough to remember SOCKS. It was an old like maybe early 90s era proxy server that would proxy sockets for you. So you'd use that like in a university setting to get out to the internet. And he wrote a SOCKS proxy in Thousand Island, and it was like a few hundred lines of code. And again, basically infinite scalability underneath that.
Thousand Island is managing those sockets and taking care of like, and so you can configure how many acceptor processes you want. So that would be how many simultaneous connections you'll be handling.
No. In fact, that's I go into this in gory detail in the MPEX talk. It's near the end of the MPEX talk that I did last week. So I said earlier that like we hand off when the process that's turning that loop, accepting a connection, processing the connection, accepting a connection, processing it. the processing part we hand off to a separate process. We spin off a handler process that goes and does that. But there's still a small window of time where you still have to do some work on that loop process, right? You still have to build a child spec, call out to the dynamic supervisor to start that process, wait for that process to start, turn back around the loop, call gen TCP accept one more time. Like there's still a small window there where it's turning around and it's not processing. And then so the num acceptors basically replicates that process n number of times. Like by default, it's 10.
Oh,
And then so the idea there is that you can still, it doesn't have any bearing on the simultaneous number of connections you have. It has a bearing on essentially how quickly you can accept them. Because you now have 10 processes that are all turning that accept loop, right? And so, you know, just statistically, if you've got one guy that's turning that and it takes him, I don't know, let's say for the sake of argument, 10 milliseconds to start a process, you know, to go out to the dynamic supervisor and start that process. Normally, that would be 10 milliseconds where you're not able to accept connections. In this case, there's 9 other processes that are able to accept connections in that interval, right? And then just
Okay.
statistically, it's going to work out that, you know, as long as you don't have this like thundering herd of 100,000 people piling on at the exact same time, there's always going to be one of those processors, those loops that are free to sort of pick you up right away.
Okay, that's awesome. Thank you for clarifying that. And that is
it's a bit of a
configurable.
subtle distinction. It is configurable. It's 10 by default, but like, so I did a bunch of benchmarking for this when I did the Elixir Conf talk last year, when I was comparing it to Cowboy, and I confess I don't really not that I don't understand, but I'm not like I don't have a great head for thinking about parallelization like this. And so I ran this on like a 64 core box on DigitalOcean or something when I was doing the demos, and I just set the num acceptors to 64. Like my reasoning being that like I've got 64 threads that are, you know, sitting there, or 64 cores that are ready to spin on this thing. I may as well let each of them spin on something. I have no idea if that's a sensible number or not. It's far faster than I need to be able to do to power a smart light bulb in my house.
No doubt. You can make like 83 million requests to that light bulb per second.
Something like that. I'll sit there on my iPhone, just hammering the on-off switch as fast as I can.
Your light bulb's catching on fire.
I wanted to say though, you'd mentioned the early internet days, the ARPANET days, about the universities and the IPs and stuff. There is a book that I finished reading over the winter called The Dream Machine. It's published by Strike Press. It's about this guy who I'd never heard of before I started reading the book, called JCR Licklider, who is one of these people that in like Forrest Gump, when he's like, he just finds himself in the middle of like every, you know what I mean, historically significant thing. You know what I mean? Like, and it's just kind of by dumb luck. He's like in the background, or like he factors into like every story that came out of the 70s. That was this dude and technology. Like he has just been kind of by dumb accident in the middle of like everything, from the earliest days of like, you know, like vacuum tube powered computers that filled an entire building at a university, all the way through to like the earliest days, like through to like the early 2000s. This dude was just everywhere, and it's basically his biography. And so they do this. He does this. It's really well written. It kind of tells the story of like his biography, but it interleaves it with like a lot of these like little vignettes about how technology developed. And they spend a whole bunch of time in that book talking about like how those early days of the internet started from like, I think it was like 8 or 9 nodes spread across the US. And then they started adding more and more on. And then they needed to automate it because it was this administrative hell. Every time they turned one on, they'd have to coordinate with like 60 other sites. And so how all of that was born, it was a very, very, very good book. I can't recommend it enough.
That's awesome. I haven't read that one, but I read a book called Where Wizards Stay Up Late: The Origins of the Internet by
That's also a great one.
Katie Hafner. Yeah, and he comes into that, but just talking about it's just fun hearing about the characters that were involved in figuring this stuff out, and like really made me appreciate TCP as an invention. It was a very pragmatic, like hammered out. I mean, they did simulations and stuff to figure out how it should work, but it was also just like, let's make it work. And an interesting side note to that is when we talk about networking, we talk about like the OSI model, which is like we talk like the link layer and the application layer and the transport layer and all this sort of stuff. But those terms come from that OSI model, which I learned in this book was actually a competitor. Like TCP/IP was working and being used, and some people were like, wait, we got to like formalize and standardize and make this like all more neat and tidy. And OSI was an attempt to do that, but it never actually it didn't end up competing well with TCP/IP.
Yeah, well, there
which
were a
was
bunch of horses
banged
in
out.
that race. There were, but I'm old enough to remember when you configured Windows back in the day, you could also configure, I think it was called IPX SPX, which I think was Novell's version of IP. And then there was a DECnet, which I think was the OSI one. The OSI one, like it, IP wasn't necessarily, the only game in town as recently as like, I don't know, the mid 90s, maybe. Apple Talk was a thing too. That was its own protocol.
Yeah, it's surprising because it just feels like this is of course is the way things are. It's interesting to know.
The stuff is young, man. Like a lot of the stuff is barely 50. Like it's not even barely 50 years old. Like we are making up an awful lot of like as a culture and as a field, we make up an awful lot of this as we go along. We always have.
It also is encouraging that we can invent new things. We've talked about Thousand Island a bit. So I guess I'm less clear on what Bandit does, because like I've got the idea of what Thousand Island does, and I've got the idea of what Phoenix does, but in the middle, Bandit is doing some work kind of translating between those two things. I sort of have the idea that like Bandit is maybe going to see like an incoming HTTP request and go, oh, the content length is this, so I'm going to read this much data from the socket.
But that's exactly what it does.
Okay.
So the idea is Thousand Island, like if you take for granted that Thousand Island, from the perspective of Bandit implements a handler on top of Thousand Island. So from its perspective, Thousand Island hands it a socket, which is, it's Thousand Island has already done the work of sitting there and listening for a connection to come in, let's say from Chrome. And then so it sits there and listens for a connection from Chrome. Somebody connects. Thousand Island does the work of taking that socket and essentially handing it to Bandit and saying, I have this socket for which you've told me you want to run the Bandit handler. Go and it's now yours. Go and do whatever you'd like with this. And then at that point, Bandit has the socket and it basically starts transacting exactly that, what I was talking about earlier, when you telnet to a port and you get /HTTP, it runs that it runs that conversation, that protocol. So it'll actually sit there and listen. I'll set aside HTTP2 support because that's completely different. It sits there and basically just reads off of the socket, because the client in HTTP, it's a client-driven protocol. So the first actor, once you connect, is going to be like the first action comes from the client. And so the server sits there and listens, and it'll sit there and read, let's say it's a GET, it'll read GET space / space HTTP / 1.1 new line. It reads all of that stuff, reads the headers, reads, like you say, the content length, the content type, and all of that stuff. Essentially takes that, packages it up into a plug.conn structure, which if you've in Phoenix, it's the same conn that you get in a controller call or basically anywhere in a plug within Phoenix. Excuse me. And it packages it up as that. So it'll read in the headers. It'll say, I've got these 6 headers. Here's the values of them, et cetera, et cetera, et cetera. Packages it up in a plug.conn structure and then calls a plug implementation. So in the case of Phoenix itself is a plug implementation. So it will call Phoenix's public, like Phoenix publicly declares itself as a plug implementation in the endpoint module. And it's around line 400 or so in the endpoint module. It actually says like def call. And that is what Bandit actually calls in Phoenix. And then after that, it's Phoenix just takes it and runs with it. And then Bandit also provides support for you to be able to like write response bodies back. So you can then, given a conn, you pass it into like, plug.conn like send response body. And then Bandit knows, like when you say like, let's say send back the body, hello world. Bandit knows how to go and properly format that as HTTP. So it will send back the headers that the client's going to expect for that. It will make sure that the content length header is set. It does all of that stuff basically to be the server side of an HTTP conversation. So again,
Okay.
underneath it, it takes for granted all of the socket stuff because Thousand Island provides it. And above it, it takes for granted Phoenix or your whatever plug application as being the application logic. It's the glue that sits in between those.
That's cool. Okay, so for Phoenix, all it really has to do is take the con it's given and return a different con that has a response on it and be like, all right, here you
That's
go,
it.
Bandit. Here's the con. It's got a body on it. Get it back to the
Yep.
client, please.
Yep. That's basically it.
Yeah, that's really cool. It's neat how those layers all work together.
Yeah, it's a really neat, it's a really, I gotta say, pretty decent abstraction. The plug abstraction is like pretty solid. There's not a whole lot. There's a few little corners. Like I've opened up a few PRs for some really obscure corners of it that are kind of unfinished. But generally speaking, it's a fantastic abstraction. Certainly anything, certainly like nothing. The things that it's missing aren't things that any normal person would ever notice. The only reason I noticed them is because I wrote an HTTP server and I was like, you know, when you live and breathe the spec for 6 months at a time, you're like, oh, it doesn't do trailers. We should do that. But no one's ever even heard of them. So
yeah, one of the things that I don't really understand with con, like the simple case where like I get the con, I return a con with a response on it, that makes sense. But the thing about like streaming, like sending chunked encoding data, I haven't grokked how that works. It's something I've been meaning to go look at.
Yeah, so it was actually I didn't correct you a moment ago, but you actually had a very subtle, you misspoke very subtly a moment ago. You said it returns, you have a con, you set a response, and then you return that con. We actually send the response when you say send the response. Do you know what I mean? So if you did something where you had like, let's say you had it was like con, send response, hello world, process sleep 10 seconds, return, you would see that hello world right away. You know what I mean? And then the process would be still sitting there. The server process would still be sitting there sleeping for 10 seconds. Like we send it to the client when you tell us to send it. And so the streaming stuff, right, just streams it when you tell it to stream it.
Okay, so plug
right?
constant
As you
response.
send it. Yeah, like 90% of the time, by the time the con, you know, you have to return a con at the end of your plug call. 90% of the time, by the time you get to the end of your call and you return that con back out, you've already, like, cons actually track their state internally, whether they're sending, whether they're initialized, they've sent, or they've completed, or they're streaming. 90% of the time, by the time it comes, like I get it back from the plug, it's already been sent. The only case where that wouldn't be the case is if somebody didn't send a response.
Okay. Interesting. Okay. And so the purpose of returning the con at that point is just so that it can make sure that the response does get sent if it hasn't been sent yet.
Yeah. And also it also lets them compose, right? Because plugs are the same abstraction that Phoenix uses internally to build pipelines, right? And it builds pipelines by the fact that it knows that, you know, if you're going through a bunch of pipelines that would, like, you know, in the Rails world would be like before filters, you know, make sure I have a content type, make sure I do authentication, you know, enforce SSL, whatever.
Yeah.
Those are taking a con and returning a con, right?
Right.
And so the fact that like the plug API mandates that you return a con is the thing that lets that chaining happen.
Right. Yeah. And we write a lot of plugs in our applications for stuff like authentication and so on.
Yeah, it's the exact same plug API that Phoenix uses internally to compose pipelines is the exact same plug API that it uses externally to expose itself to like a web server like Cowboy or Bandit. It is the same API.
Any of you other folks have anything you want to jump in and say?
So what's the next step for you with Thousand Island and Bandit? Maybe you've already talked about this in your recent talk, but what's the next step in terms of broader adoption for these libraries?
Well, the big thing that I announced last week at MPEX was that we now support Phoenix applications within, because we didn't, as of the release that went out at ElixirConf, it supported plug apps but not Phoenix. As of the release that went out with MPEX, we now support at least HTTP Phoenix apps. So we still don't do WebSockets, but anything that uses, like, for example, all of the stuff that PagerDuty uses Elixir for internal at everything that PagerDuty uses Phoenix for is all APIs. It's just APIs. So, like, in theory, we could sub in Bandit for Cowboy tomorrow and it would work just fine. There's no streaming, there's no WebSocket work. Everything that isn't WebSockets in Phoenix, we should support. If we don't, it's a bug. WebSocket support is the next thing. So that's quite a bit trickier. That, if you want to talk about networking models that kind of melt your brain, WebSockets is one of them. Like I just wrapped my head around this stuff like a few weeks ago in terms of how I'm going to go about implementing it. I was always like, I have a rough idea. It'll be over there somewhere. It'll kind of look like that, but I hadn't sketched it out in any detail. I just wrapped my head around that a few weeks ago. So WebSockets work. I'm going to try to land, I always say within a couple of months, but realistically it'll be it's summer. So realistically the fall, I think. At that point, being able to the hope is that we would be a drop-in replacement for Cowboy everywhere, including Phoenix. I think that's when things get really interesting, right? Because that's when we can really start pushing on, having better telemetry support, having telemetry support, period. The scalability story and the performance story is significantly better than Cowboy. It's a lot more readable, right? But none of that really matters to people. Like I hear this over and over and over when I talk about Bandit at this point. They're like, this sounds great. Let me know when it supports Phoenix. You know what I mean? Like, no, like it's great in the abstract, but until it's something you can actually use today without really having to think too much about it, nobody really cares. You know what I mean? Like they're interested in it academically, but nobody, really cares from an adoption perspective. I think once it becomes a drop-in replacement for Phoenix is when that gets really interesting.
And part of why I wanted to have you on the show is to get people excited, looking forward to this, ready to try it out when it's ready, maybe even jump in and contribute to getting some of that work done if they're able to do that.
Absolutely. I'd love to help. I was going to say, like a really encouraging thing with that. So when I had a back and forth with Chris McCord about this a few weeks ago when I was landing the Phoenix support. And it came to pass in you can see this on, I think it's a PR on the Phoenix app somewhere. I can't, if you just look for Trudell in the Phoenix application, in the Phoenix project, you'd find it. But the back and forth, the gist of it at the end was essentially that like the Cowboy support is explicitly in Phoenix right now because there is no sort of formalized, there's no plug API for WebSockets, right? Like there's the plug API in the Elixir world for HTTP connections, but there's no analogous API for WebSocket connections. And so the Cowboy support that's explicitly in the Phoenix project is there because it has to be, because there's no abstraction. And then so where we left it was, I'm going to go off and build that abstraction. I'm going to build to that abstraction with Bandit, and then I'm going to build to that abstraction with Phoenix. And then we will then take the Cowboy stuff out of Phoenix, move it over into the plug.cowboy repo. And Cowboy and Phoenix at that point will be completely agnostic. Like there will be, the end goal here is that there is no Cowboy specific or Phoenix specific code in Phoenix. It is just, at that point, it literally just becomes a plug and whatever the API ends up being called for sockets, right? Like it's a plug client, it's a plug application, and that's it.
Yeah, that's really cool. If we could back up a little bit, there's a couple of things I wanted to ask about having something like Cowboy or Bandit involved. A lot of times when people put applications up on the internet, they're going to put something like Nginx in front of it as a reverse proxy. And in a lot of languages, you really need to do that. But you don't necessarily need to do that with something like Cowboy or Bandit. I'm just curious, like, what are sort of the trade-offs of having Elixir handle a request directly without having a reverse proxy there? Is there any kind of like extra control that it gives you to have that layer at your fingertips?
Well, I mean, in theory, I think it does, right? So I think the idea here is that, like, the classic example is, in the old days when we all ran our own servers, you'd have Nginx in front of, be it Rails or Cowboy or Phoenix or whatever it was. Excuse me. And that was, kind of certainly necessary in the Rails world because you'd have, so they were essentially single processed servers. So they, you'd want to get whatever the request was done as fast as possible so you could service the next one. And then Nginx's job was primarily one of buffering. So if you have a client at the far end of, let's say in an extreme case, at the far end of like a dial-up modem or something, right? It makes a single request that is going to take let's say 5 seconds for it to actually get through the network back to the client. You want Nginx to absorb that 5 seconds, not Rails, because you'd end up with, you'd basically only be able to process one connection every 5 seconds. Whereas once you throw Nginx in front, you can process as many as you'd like. And Nginx does a very good job of this. I've just received 5 megs of data from my Rails app, and I am now going to buffer that out as slowly as I have to back out to this guy at the end of a dial-up modem or something. You don't have that concern in Elixir, right? Because every process that's in your system can take as long as it likes. You don't have a single, like in Rails, where you have a single thread coming around processing every connection. You could be at the end of a dial-up modem on Mars, and sure, that process would take that connection would be slow, but nobody else would know or care. So that part of it definitely is no longer, it doesn't do you much harm to have Nginx in front, but it's not necessary for the classic reason that people used to do that. The security side of it, I'm out of my element. I don't frankly know enough about like what kind of the difference in security posture you would have between those. I would imagine there's probably something significant there. And I mean, the reality is now we all have load balancers in front of us that it's just on a computer that Amazon owns, right? Like it's the same general idea. It's just a load balancer that we talk to via an API. And that again has a bunch of other necessities just from a deployment and, scalability and, all of that perspective.
Yeah. One thing that I was thinking about is, like, let's say you have an endpoint where somebody is supposed to be able to send you a post request with like a profile pic, and you're like, hey, this should be like, no bigger than 10 megs or something. And somebody is sending you a post with a gig of data, right? You can configure Nginx to have a max post size there.
Yep.
But I'm wondering if, when you're using something like Bandit with Thousand Island, do you have sort of a control level where you can say, hey, stop reading when you see, close that socket when you see that much data coming in?
So the interesting thing, I didn't know this until I started writing this, is that's actually exposed via the plug API. The plug API read rec body function, I think it is, returns a tuple that's like, it has one. It's like, I don't know if you ever seen like the more style tuples. They're really common in networking code. So like when you're trying to read something and through an API that uses this, for example, you'll either get back like, okay, here's a response, or you'll get back a tuple that's like :more. And here's the stuff. And it basically says, here's the stuff I have now, but there's still more. So ask me again. Right. And the expectation is that it'll give you back a continuation that you pass in a subsequent time. And that's the pattern that the Phoenix plug, the plug pattern actually uses that for request reading. And I think it chunks out at if memory serves, I think it's 16 megs at a time by default, but you can pass that as a parameter when you request the body. And so you basically tell plug, read the request body, 2,000 bytes at a time. And it will give you back, it will read 2,000 bytes, it'll hand you back 2,000 and it will say more. And then you read another 2,000 and it'll say more. And so it's really, the answer to your question is that's actually already in the purview of the application on the other side of the plug boundary. That's already Phoenix's really problem. Cool.
That's really
I didn't know that either until I wrote this. I was surprised by that.
Okay, so in the setup with Bandit, I would be saying read another however many bytes from the plug, and that would be then Bandit would then turn around with Thousand Island and receive that many. It's read that many bytes off the socket.
Yeah, Bandit obviously supports that part of the API, but that the expression of that policy is intended to be on the upper side of the plug boundary.
Okay. One other kind of like esoteric, question that I was thinking about is a problem that I used to notice, or I realized what could happen in Rails, because I came into Elixir from the Rails world. In that world, you would have, like you were talking about, like a single process doing the handling incoming connections, or maybe you would run something where you have multiple threads, like Puma or whatever. You have multiple threads doing this, but you have a fixed number of those. Like maybe you have 10, let's say. And so at the OS level, my understanding is there's like a listen queue where if you can read 10 at a time and 11 come in, one of them is sitting in line.
Yep.
And at the OS level,
Yep.
it's like I'm waiting for somebody to accept this connection.
Yep.
And so sometimes you would, if you were getting saturated on a Rails application, your measurements would say, "Oh, I handled this request in, 50 milliseconds or whatever." But that doesn't show you the fact that that client, because you're actually saturated, that particular request sat in the listen queue for maybe 200 milliseconds, and you can't see that.
Right.
I'm guessing we still can't see that with Thousand Island because that's kind of that's past the boundary of the socket, right? That's like off in the OS territory.
It is, and I believe there's a bunch of dials and knobs you can tweak with this in Thousand Island. We just passed all of this config stuff into the underlying the socket libraries. So they have, and there are these super esoteric sock _ e-adder reuse and like these obscure names that have been the same since like 1976. There are some knobs and levers there to handle this, the depth of the queue and what to do when it backs up and whether you refuse the connections outright, that sort of thing. I believe you can get into the stats on that if memory serves, I don't track those right off the bat in telemetry, but I think that you can look at them via there's a get info function on that you can pass the Thousand Island exposes on sockets where you can get it's basically like a key value store that the OS provides to you for a bunch of different things. So stats, the number of octets that have gone back and forth, the number of packets, the number of errors, that sorts of things. I believe one of those numbers is that queue time. But It's a good point. That would actually be a good thing to expose in telemetry.
But you're much less likely to run into that problem with Elixir just because, like you were talking about, you can just keep spawning a process for each incoming thing.
And you've got 10, like I said, by default, you've got 10 listeners that are all sitting there waiting, right? So
yeah,
if like, and I recognize that nothing in concurrency happens simultaneously, but if you did have 11 connections simultaneously dump onto your server, to your point, you would have the last one of those would queue for some length of time. I don't, like I said, and we don't model that number, but I believe we do have access to it.
Yeah, but because your acceptor processes are then going to spawn handlers, they can go back to accepting much faster than say in the Rails scenario where it's got to wait until you actually send the whole response.
The reality is that 11th connection in that scenario would only block as long as it takes for that acceptor loop to basically turn around again. So as long as it would take for it to go and wait for that supervisor process to start, turn back to the top of the loop, call accept again.
Yeah.
So it's going to be it's going to be deterministically short as opposed to dependent on the length of on however long that connection takes.
This has been a really fun discussion. I don't want to keep you all day long. Any of you other folks want to jump in and ask anything else? I've again kind of dominated the discussion. Andrew, Brooklyn, Mike, anything you want to ask or say?
So if someone does have a Phoenix HTTP application and wanted to start using Bandit instead of Cowboy today, are there instructions for that already published?
Yeah, it's on the Bandit README. It's a one-liner. Obviously you first have to add Bandit as a dependency of your project, just like in your mix file. And then you add, it's like adapter : bandit.phoenix adapter in your endpoint config. It's a one-line change. I actually live demoed the change at MPEX. So it's a small enough change that I managed to do it on stage, typing over my shoulder, looking at the projector. So that's about as trivial of a change as you're going to get.
All right. This has been really, really fun, Matt. Thank you for talking with us, and I'm really excited to see what's next with Thousand Island and Bandit, and I do hope that we get to see this as the default network stack in the very near future.
That's an ambitious goal, and I want to really be clear about this too, that like I don't personally see anything wrong. I certainly don't have any bad blood or anything with any of the existing stacks. You know, I've got nothing but love for Cowboy and Ranch as apps. You know, I don't intend for this to be competitive or to be, you know, acrimonious in any way. It's frankly, it's like I say, it's a fun thing that I kind of fell backwards into, and I think it, you know, really does. This is what I keep saying over and over and over, and every time that I have a chance to talk about this, right, is that like this stuff is not scary. You know, people think about networking as like this. I couldn't possibly understand that. It's, you know, it's that's for the, you know, for the long beards and the, you know, like the hardcore developers. This stuff is not hard. It really, you know, I mean, there are some like, you know, like subtleties to it, but it's not impenetrable. It's the same stuff you've seen everywhere else in Elixir. You know, it's gen servers, it's supervisors, it's a couple of Erlang function calls. That's about it. There's really nothing to it. So, you know, I think having an Elixir version of this stuff that people can go and look at and kick the tires on, and maybe go and write their own, like you say, email server, you know, really, if I manage to do nothing else with this other than to demystify this stuff for, you know, for developers, I've succeeded. That's really, you know, the main thing here is that this stuff, like most things, is, you know, we have these tools now in the world that have gotten to be so complicated and so layered that nobody understands them from top to bottom anymore. You know, like nobody understands how their application deploy in a big organization. Nobody understands how their application deploys soup to nuts. I push code to main, and somehow or other the SRE folks figure it out that it gets out to the site. I don't know how. What the hell's a nomad? I don't know. You know what I mean? Like it's at this point where everything is just an abstraction on top of an abstraction on top of a riddle on top of a vest. You know, and being able to go the other way with that and be able to show people that like you can actually go down a layer and it's not that scary, I think is a big part of it, right? It's just sand that we've made to know what to do math. That's all it is.
Well, thank you so much for coming to talk to us, Matt. It's been a lot
been a
of
pleasure.
fun. Yeah. So thank you to everybody who has watched or listened to or otherwise consumed this show. If you've enjoyed the show, please connect to your nearest website with Telnet and type a rave review in HTTP format.